Hi everyone, welcome to week 6 of distance learning. This week's topic is going to be exponential growth and decay. We have actually already done this in class, so this is going to be a review for you. It's just one of those tough topics that we thought you needed some more explanation in and some more practice in. Okay, so the main formula that we're going to be using is the y equals c times e raised to the kt. There are these different bullet points that explain to you what each thing means. So y is the amount at some given time. So it's not the amount that you start with, but if I say after 5 days how much is left, that would be asking you to figure out what y is. C is the initial amount that's present. So if I say I start off with $200 in my account, then the 200 would be C. E is not a variable. So make sure that you are not substituting anything in for E. It is not a variable, it's a number. It's about 2.718. It's something very similar to pi, where it's a special number and we just gave it a symbol. K is a growth constant. It's not written as a percentage. It's always going to be written as a decimal. So whatever number you're given, you're going to need to take that and convert it into a decimal before you put it in your formula. T is going to represent time, and it's your independent variable. So let's do an example. I've got a culture that contains 400 bacteria. 5 days later, it has 1,000 bacteria. So the 400 that's there, that's giving me C because that's the initial amount that I started with. The 5 days later is giving me T, it's telling me the time. And then containing 1,000 bacteria, that's telling me Y because it's saying after this time, after 5 days, I have this amount of 1,000 bacteria. So let's write the equation. So our main equation is Y equals C E raised to the kt. I know that y is equal to 1,000, so I'm going to replace that. I know c is equal to 400. E never gets replaced because it's a number that just has a special symbol. It's not a variable. K, I don't know what k is, so I'm just going to leave it as k. And then t was given to me as 5. So if I write this and I make it look pretty, I'm going to put the 5 before the k, and that's what we have. In order to write an equation, it says write the equation which describes the amount of bacteria, y, as a function of time, t, in days. That means that the two variables that should be in my equation are y and t. So my equation needs to be y equals something that has the letter E, which is not a variable, and then T, which is a variable. So what I need to do here is solve for K. So I've got my equation 1,000 equals 400 E raised to the 5K. I'm going to start solving this by dividing both sides by 400. So that gives me 2.5 equals E raised to the 5K. Now, my issue is that the 5 and the k are up in the exponent. I need to bring them down on the same level as the 2.5 and the equal sign. So I need to get rid of that base e that's there. Whenever you have a base number that you want to get rid of, you can take the log of both sides using that same base. So in this case, I would need to take log base e of both sides. Log base e has a special name. It's the natural logarithm that's abbreviated with ln. So I'm going to take the natural log of both sides. So what's going to happen is this ln and the e are going to kind of cancel each other out. And you're going to have ln of 2.5 equals 5k. Now, if I want to get k by itself, I just need to divide both sides by 5. So k is going to be ln of 2.5 divided by 5. You can just type that in your calculator and round it. So you're going to get about 0.183. And that is my value for k. So when I write my equation, I'm still going to be following this format, but I'm going to replace C and K. Only C and K. Everything else is going to stay the same. So I'm going to have y equals C, which is 400, e raised to the k, which is 0.183, and then t. And that's the equation that it's looking for. The reason we write it like this is so that if it gives me a time, I can easily plug that time into the equation and get a number out. Or if it gives me an ending amount, like it says how long will it take for there to be a certain amount of this item, then I can easily substitute that for y and then solve for t. So that's why we keep the y and the t as those letters instead of replacing them with the numbers. So the next part of the question says how many bacteria will there be in 20 days? That 20 days is telling me the amount of time. So this is saying t is equal to 20. So I'm going to take my equation from the previous question, and instead of writing a t, I'm going to replace t with 20. And you're just going to put that into your calculator, and you should get 15,625, and it's talking about bacteria, so we're going to write that unit. Okay. The last part asks how long will it take for there to be 1 million bacteria? Highlight that. So that is telling me that y is equal to 1 million because it's giving me an end value. So if I use my equation, I'm going to substitute y with 1 million. I have no value for t though. So the only variable that's missing is t. That means that it wants you to solve for t. So from this point, we're going to solve for t. So in order to do that, I'm going to divide both sides by 400 first. And that's going to give me 2,500 equals e raised to the 0.183t. So similar to when we did the solving for k in the first portion of the question, I need to solve for t. I need to get it out of the exponent and bring it down to the same level as the 2,500 and the equal sign. So I'm going to take the natural log on both sides. So the ln and the e are going to cancel each other out, and you're going to have ln of 2,500 is equal to 0.183t. So to get t by itself, I need to divide both sides by 0.183. So these now cancel, and t is equal to the natural log of 2,500 divided by 0.183, and that's going to give us 42.694. And it's asking how long it will take, so we're going to say days. Okay, so that means that it's going to take about 42 to 43 days for there to be 1 million bacteria in that culture. Okay, next we've got a question about radioactive material that has a half-life. Please pay attention, extra close attention to this question. This is going to be sort of similar to one of the reflection questions, so make sure you star this or highlight it or something. So there are 200 grams of radioactive material, and they have a half-life of 10 years. So first thing I need to write an equation that's going to model this situation. So we're still going to be using the y equals c times e raised to the kt. I know that C is equal to 200 because it says I started with 200 grams of that material. The value of y is the amount that is left after a certain amount of time. So what I'm going to be doing after a certain amount of time is taking half of the original amount because it's telling me that I have that half life. So I'm going to represent y as half of C. So I'm going to put 0.5, that means half, of C. Okay, C is my original amount. The time that it's giving me is 10 years. It has a half-life of 10 years. So I'm going to substitute all of that into my equation. Since the y value is half of c, if I do 0.5 times c and c is 200, that's just asking me to take half of 200, which would be 100. So the value for y that I'm going to substitute is 100. C is 200. Then I've got e raised to the k times t, and t is 10. The way that I did it on the notes key looks a little bit different. It gets you to the same answer, it just looks a little bit different. So I'm going to start here by dividing by 200 to solve for k. So 100 divided by 200 is a half, so 0.5. And then I've got e raised to the 10k. Okay, so in order to get that 10k out from the exponent, I'm going to take the natural log on both sides. So these cancel. And then I want to get rid of the 10 in front of the k, so I'm going to divide both sides by 10. And if you put ln of 0.5 divided by 10 into your calculator, you're going to get about negative 0.069. So your equation is going to be y equals, c is 200. Remember, e is not a variable. K is what I just solved for. And then I'm going to leave the t. So whenever you're writing these equations, the letters that should be left in there at the end should be y, e, and t. If you don't have all three of those letters, go back and rewrite it so that it looks that way. Okay, so how much radioactive material will there be in 100 years? Well, that's just telling me that my time is equal to 100. So I'm just going to take my equation, and instead of putting a t, I'm going to replace that t with 100. And if you put that in your calculator, it's going to give you 0.195, and my units here are grams. Okay. How long will it take for the material to decay to 1% of its original amount? So that's telling me a y value, because it's saying after a certain amount of time, you're going to have 1% of it left. So that's telling me that my y value is 1%. 1% as a decimal, that's going to be 1 divided by 100, would be 0.01. And it's 1% of C. So I'm going to put a C because C would be my original amount, and I'm taking 1% of that. So if I multiply 0.01 by C, my C is 200. 1% of 200 would be 2. So I'm going to substitute that into my equation. So I've got 2 for y equals 200 e raised to the negative 0.069 t. So the variable that we have left over is t, and that's what we're going to be solving for. So I'm going to divide both sides by 200. 2 divided by 200 is going to give us 0.01. Okay, and then to get that exponent on the same level as everything else, we're going to take the natural log on both sides. So these are going to cancel, and we're going to have the natural log of 0.01 equals negative 0.069 t. And to get t by itself, you need to divide both sides by negative 0.069. So you would type this into your calculator, and the value of t that it's going to give you is 66.439, and that's just an estimate. And it's asking how long it will take, so we're going to say years. The part that's underneath of this is just exploring a different way of looking at exponential growth or exponential decay. This would be used in more of a financial situation. So if you're talking about interest on an investment or depreciation of the value of an item. The big piece that's kind of changing here is that this percentage is not going to be K from the formula that we used before. It's going to be changed into a value that's going to be added or subtracted from 100, but mostly everything else stays the same. You're going to see the letter R as a growth rate. Again, make sure that we're changing this to a decimal when we're looking at it in our formula. So let's look at this example. So we're purchasing a new car. It's crooked. And our new car is worth $24,500. So that's telling me C, because the initial amount that I purchased it for was $24,500. As soon as you drive away from the dealership, the car is going to be depreciating. Depreciating means that we're going to be decaying at a rate of 5.5% per year. And this is giving me R. Okay? So I have my equation. I'm going to be using exponential decay. Decay means that you're going to have, let me zoom in a bit. C times 1 minus R. If this was growth, you would see 1 plus R. But since it's decaying, we're going to be going below 100%, so we're doing 1 minus R. And we're going to raise that to the T. So I know that my value of C is 24,500. I know that I'm decaying, so I use the correct formula. My value of R would be 5.5%, but I would write it as a decimal. So you would do 5.5 divided by 100, and that would give you 0.055. So that number is what's going in the equation. So we've got Y equals 24,500 times 1 minus R, which is 0.055, raised to the T. I don't know what T is, so I'm just going to leave it. So if I simplify this, I'm going to get Y equals 24,500 times 0.945 raised to the T. And that's my equation. So I've got the Y as a variable and I've got the T as a variable. I can plug numbers into that and make inferences based off of that. So the next question says, how much will the car be worth in 10 years? So that 10 years is giving me that time is equal to 10. So I'm just going to take my equation, and instead of writing a T, I'm going to substitute that T with 10. If you put that into your calculator, you're going to get 13,915.03. And since we're talking about the worth of a car, this would be in dollars. So that is our answer for that part. Now we're looking at how long will it take for the car to be worth only 15% of its original value. So that 15% that it's giving me is a Y value. It's saying that after a certain amount of time, I'm going to be left with 15% or 0.15 as a decimal of the original amount that I have. So I'm going to put 0.15 times C. Well, the original amount that I paid for the car was $24,500. So if I multiply that, it's going to give me 3,675. So in my equation, I'm going to replace Y with 3,675. I've got my 24,500. 4,5. I don't know what T is. It's asking me to solve for T because it says how long. So I'm just going to leave T as a variable. So I'm going to need to solve this equation for T. So I'm going to start by dividing both sides by 24,500. And we're going to get 0.15. Now, I need to get this t that's here away from the exponent. I need to get it on the same level as the 0.15 and the equal sign. If you were in Miss Serio's class, we did this as like a challenge problem, and I gave you, I think, like a homework pass or something if whatever team solved it first. You're still going to use natural log. Even though you don't see the e there, you can still use a logarithm, and you can use those properties to help you solve the equation. So I'm going to take the natural log of both sides. And the trick I'm going to use here is the power rule. The power rule says that I can take an exponent and I can move it into the front of a logarithm. Okay, so I'm going to have the natural log of 0.15, and then using the power rule, that t is going to now be in front of the log. Now that I don't have exponents and everything's on the same level, if I want to get the letter t by itself, I'm just going to divide by the natural log of 0.945 on both sides, because it's going to get t by itself, as these are going to cancel. So that means t is the natural log of 0.15 divided by the natural log of 0.945. If you put that in your calculator, you're going to get 33.536. And since it's asking how long, our units are in years. So these problems do take a while to figure out. There are practice problems posted on Google Classroom. There are also solutions to those practice problems that are posted. That is not graded. That is just there if you want to practice before you try the reflection questions. If you are in regular PreCalc, there are 5 questions total on that document. You only need to do the first 3. So the last 2 questions are a pre-AP extension. The key for those is still posted, but if you're in pre-AP, all 5 of them are applicable to you. But if you're in regular, just the first 3 are what you're going to be seeing. So if you want to, go ahead and do that. And if you do like the first 1 or 2 problems and you feel okay with the concept, then don't do the rest of them. It's just there if you want to practice. Again, that is not a grade. Don't turn it in. Don't think that you have to do it. It's just there if you want to practice. I will say that number 3 on the practice problems is going to be very similar to your reflection question. So please take a look at that, and at a bare minimum, just do that one problem, because that's going to help prepare you for the reflection questions. If you've got any questions about anything, please email your teacher. Thanks for watching. Y'all have a great day.